Oh, this last lesson in Unit 1 is about cylindrical and spherical coordinates. I would assume you'd like to learn about them.
Yeah, baby!
Alright, so let's talk about them. Cylindrical coordinates will be extremely familiar with you. It's just like sticking a z-axis above the xy plane when xy is given in polar coordinates. So maybe I should say it's like an r theta plane with a z-axis stuck on top. And I'll do a little picture of it. Here's a point in three-dimensional space, and this point in two-dimensional space would be given coordinates r theta if we're in polar coordinates, r being the distance in this plane from the origin to the point, and theta is the angle from the positive x-axis to the point. But then we have z, which is the height above the r theta plane, or if you want to call it the xy plane, that's what it is. So this point could be listed as xyz. X is this distance, y is this distance, and z would be the height. And or it could be listed as r theta z. R is the distance to actually the point's projection into the xy plane, or the r theta plane, and from the origin to that projection, and then the angle theta from the positive x-axis, and then the height above the r theta plane, or the xy plane, whatever you want to call it. So that's cylindrical coordinates in three-dimensional space. So you might recall converting. That was always easy to do. X equals r cosine theta, y equals r sine theta. You could get this right from the definition. Cosine theta is x over r, sine theta is y over r. Done. And of course z equals z, nothing special there. And when we go from rectangular to polar, which means rectangular to cylindrical now, you can just say r squared is x squared plus y squared, and theta is the angle whose tangent is y over x, and again, of course, z equals z. Right, that's correct. So in both types of conversions, the z is the same. In fact, we could say cylindrical coordinates are just polar coordinates with a z-axis orthogonal to the r theta plane. That's it. That's the whole story. So let's do one. Convert to rectangular. The point r is 5, theta is 4 pi over 3, and z is 4. So r is 5, and x would be then 5 cosine of 4 pi over 3. Now you got to think cosine of 4 pi over 3. 4 pi over 3 has a reference angle of 60 degrees, and cosine of 60 is half. But 4 pi over 3 is in the third quadrant, and in the third quadrant x is negative, so cosine is negative. So that would be 5 times negative a half, or call it negative 5 halves, right? Sine of 4 pi over 3, again, is in the third quadrant, but the reference angle is 60 degrees. Sine of 60 is square root of 3 over 2. So this would be negative 5 square root of 3 over 2, because it's in the third quadrant where sine is negative. So, and of course z is just z, so 4. So there it is. Here it is in cylindrical. Here it is in rectangular. And here it is plotted. So now let's go the other way. Let's change rectangular to cylinder, or cylindrical, and sketch. Well, for cylindrical, if this is x and this is y, r is the square root of x squared plus y squared, so that would be the square root of 1 plus 3 square root of 4, which is 2. So our r is 2. Theta is the angle whose tangent is y over x, which would normally we'd say is just the square root of 3, because a negative over a negative is a positive. But they're both negative, so we know it's in quadrant 3. And recall, arctangent only gives us values in quadrants 1 and 4. This has to be in quadrant 3, so we have to add pi. And so we add pi and get 4 pi over 3. And so, and of course the z is still 2, same as before. So, did I list it anywhere? I didn't list it anywhere, so I should list my r theta z. So it would be, as an ordered pair, it would be 2, 4 pi over 3, and Z is also 2, so 2. So there it is in cylindrical coordinates. So it was this in rectangular, there it is in cylindrical. Here it is in a picture. So 2 units this way, 2 units from here to here. I'm not drawing the scale, and the angle 4 pi over 3. So there's really, I should mention this. There's really an infinite number of choices. If you need to go back and review polar coordinates, remember 4 pi over 3 plus any multiple of 2 pi will work. And also, if r is -2, we could pick theta equal pi over 3. So in other words, this angle, but r is negative. That would still give us the same spot. Okay. So remember, cylindrical coordinates like polar gives us a way to simplify some surfaces. Well, it's like it simplifies some equations of like things like Limassol and the like. But in cylindrical, we have an infinite number of ways of notating the same point. Okay. Video 1 is over. Have you had enough?
Well, yes.